Hey, good morning, everybody. This is Mr. Ainsworth again, and we're going to get into your AP Pre-Calculus homework here in Unit 5, Section 7. And I'm not going to do all of them, so just understand that. Okay, so let's get in it, or let's get on it, however you want to say it. Okay, it's late today, and oh my God, it's almost 8 p.m. I can't believe I'm doing this, but I'm doing it for you guys. All right, so wife's not happy, but I'm going to do it anyways. So here we go. We got 4 to the x power equals 64. What we want to do is create equal bases. All right, and so what we want to do is take a look at powers of 4, because this is 4 to the x power. So we want to see if 64 can be written as 4 to some power, and it can. So here we go. 4 to the first is 4. 4 squared is 16. Guess what? 4 cubed is 64, because if you multiply 16 by 4, you get 64. So what I'm going to do is I'm going to rewrite 64 as base 4. So I got 4 to the some power is equal to 4 cubed. Okay? All I did was rewrite or re-express 64 as base 4. So rewrite as base 4. Now we have a little property here called the one-to-one property, and it states that if you have two exponential expressions where you have equal bases, that's pretty obvious. We have equal bases right here. Guess what? The exponents have to be equal. So exponents are equal. Kind of goes with the common sense here. So what does that mean? It means that x is equal to 3. And then why is that true? Well, it's true because 4 cubed is 64. All right, so you can intuit intuitively, or you can use the one-to-one property. Either way, you get x equals 3, okay? All right, like I said, I'm not going to do all of them, so here we go. Let's try another one. So e to the x equals 18. What we want to do is switch forms, and this is in the learning targets. All right, we want to go from exponential form, all right, to log form. And there's different ways to do this, so I'll tell you what. This is method 1. I'll show another method after this. So method 1 is switch from exponential form to log form, and this is base e, which is the natural log. So I could rewrite it as the natural log of 18 is equal to x. Notice that it's base e here, which is the same as e to the x equals 18. So you switch to log form and then evaluate, and this requires a T84. I don't have a T84 on my iPad, so I'm just going to whip out Desmos here. And we're going to take the natural log of 18. Okay, so go to functions, and then scroll down to where you see the logs. There we go. You can go to the keyboard as well. You just type the natural log of 18 and you're done. And round it, it's about 2.89. Okay, 2.88, 2.8904. So x is equal to approximately 2.8904. To the nearest 10 thousandths. Oh, this is nearest thousandths. Okay, so x is equal to approximately 2.890. Okie dokie, artichoke. Okay, so here we go. That's the first few. Let's continue. Like I said, I'm not going to do all of them, so let's go to number 5. Now here, if you have two equal logs of the same base and they're both base 10, okay, so notice that we have equal bases. Okay, when that happens, the arguments are equal. If I can spell that right. it's too late. I can't, oh my God, my spelling is atrocious. So arguments, okay, are equal. So what does that mean? It means that the first argument, which is x squared plus 5, is equal to 21. Okay, so we have x squared plus 5 is equal to 21, and all we have to do is solve it. So let's subtract 5. We have x squared equals 16. So you got to think, what number squares are 16? Well, guess what? One number is 4, the other number is negative 4. Or you can write it as plus or minus 4. There are two solutions. Now you just got to be careful. Are these both solutions of the log? And you just got to make sure that these solutions don't make the argument negative, because remember, the domain of a log is always positive. So if I take a look at the domain here, domain means that x squared plus 5 has to be positive. Okay, greater than 0 means positive. Neither x equals 4 or negative 4 makes this negative, so we're all good. These are good solutions. Okay, nothing's extraneous is what I'm saying. Okay, number 6. All right, now here we go. Now if we have 5 to the 7x minus 2 power, that equals 125. I'm going to write it big and bold over here so I can see things better. And what you want to do is try to re-express 125 as base 5. All right, so here we go. 5 to the first is 5. 5 to the squared is 25. Guess what? 5 cubed, which is 25 times 5, is 125. So I know that 5 to the 7x minus 2 power is equal to 5 cubed. Well, as I said earlier, if you have equal bases, the exponents are equal. That means 7x minus 2 is equal to 3. Okay? Now the other one says, hey, guess what? If you have two equal logs, the arguments are equal. So that means 4x is equal to x squared minus 5. Okay, it just says complete the statement. It doesn't say solve the equation. If we wanted to solve for x, we'd have to continue. This just tests to see if you know the one-to-one property. 1-to-1 property of logs. Which, guess what, is in your learning targets, guys. So if you go back into your learning targets, you'll see it. That's why I always suggest to you guys is to go back to your learning targets, consolidate everything, and actually make a summary sheet of everything you've learned in the chapter or the unit. Because guess what? You're going to be tested on it. So I would definitely do that. Now here, you want to condense the logs first. To do that, though, the coefficients must be 1. I'm talking about the coefficients of the logs. So I'm writing that down because it's a very common mistake. Okay, so coefficients of logs must be 1 to in order to condense, and they are. It's 1 log base 4 of x, so there's one coefficient 1 is here and here. So we can condense. And you go to you go from sum to product, as I've talked about in class. So we're going to take log base 4 of x times x minus 6, and that's going to be equal to 2. Simplify or distribute, however you want to say it. X times x is x squared, x times 6 is, or negative 6 is negative 6x, and that's equal to 2. Now you switch to exponential form. Again, changing forms on a log is like needed in order to do solving. So 4 squared is equal to x squared minus 6x, which means you have 16 equals x squared minus 6x. Okay, and so now you want to set it equal to 0. So subtract 16. And so we have 0 is equal to x squared minus 6x minus 16. And then you got to factor this bad boy into two binomials. And you want to find two numbers that multiply to negative 16 and add to negative 6. And so I think that's, negative 8 and 2. So x minus 8 times x plus 2, that'll probably work. Distribute through and check, of course. And you got to find zeros. And just by inspection right here, we have one 0 at 8 and the other 0 at negative 2. But then you got to find the extraneous one. And so here on the original log here, okay, the domain of the first log is all positive numbers greater than 0. So positive only. So notice I'm putting this stuff in red. So if x can only be positive numbers, then this becomes extraneous. If I can spell it. Okay, which means that it's a solution that does not satisfy the equation. Solution that does not satisfy the equation. Okay, so we only have one answer here, guys, and that's 8. Okie dokie. All right, and that's number 7. All right, number 3. Number 8. Okay, so here, now we got 3 to the power of x squared plus 4 is equal to 1/3, but 1/3 is 3 to the negative 1 power. So you just saw me right there. I want to rewrite with base 3. So rewrite, okay, with base 3. Why? Well, guess what? The other one's base 3. So if the bases are equal, as I've said before, bases are equal, that means the exponents are equal. Okay? So what does that mean? It means that x squared plus 4 is equal to negative 1. And how can that happen? All right? This is positive. X squared is positive. 4 is positive. Positive plus a positive, guess what? That's positive, and that can't be equal to a negative. All right, so there's no solution here. All right, and I just explained it. It says explain. Well, I just explained it. Okay, so there you go. All right, now number 9, it says write an equation for f inverse. So this is the inverse of the function. Okay, so first of all, we have y is equal to log base 4 of 3x plus 7. I'm going to go to exponential right here. So I have 4 to the y power is equal to 3x plus 7. I'm going to subtract. Oh, scratch that. It's getting too late. Start over, Ainsworth. Sorry, switch variables. Okay, I got x is equal to log base 4 of 3y plus 7. Sorry. Almost major boo-boo there. So switching x and y here. And then now you got to solve for the original variable. So here we go. Now we go to exponential form. So 4 to the x power is equal to 3y plus 7. And now we solve for y. So I'm going to subtract 7 on both sides. So I have 3y is equal to 4x minus 7. And divide everything by 3. Y inverse is equal to 4x minus 7, all divided by 3. If you want to divide both of them by 3, you can. So 4x divided by 3 minus 7/3. But here, I wouldn't do that. I would just leave it as the first expression here. Okay? Either one's fine, though. Okay, and the last one. So we have this f of x is log base 8 of x. And g of x is an exponential function, 16 to the x, and find the composition. So this is find h of x equals w. So I need to figure out, first, what is f of g of x? Okay, so and I got to substitute g into f. Okay, so I got to take g and substitute it into f. All right, so let's do it. So I got to take log base 8 of 16 to the x power. All right, and that's equal to w because it says h of x is w, and it says find the solution in terms of w. All right, so I gotta solve for x. Okay, so here we go. I'm gonna go to exponential form again. Okay, at least I think that's what I'm going to do. Actually, no, I'm not going to do that. I'm going to use some log properties. Okay, I'm going to take here, I'm going to shift it to the coefficient. That's what I'm going to solve for x. So I got x times a log, all right, base 8 of 16 is equal to w. And then I solve for x, and I get w divided by log base 8 of 16. It'd be kind of nice to know what log base 8 of 16 is. So I'm going to do a little side work over here. I need to know what log base 8 of 16 is. So log base 8 of 16 is some unknown quantity. I'm going to call it question mark. Okay, so 8 to some power has got to be 16. You know what? Let's call that question mark. Let's call it Z, just for funsies. Okay, let's call it Z. So Z here, 8 to the power Z equals 16. Got to solve for Z. And then, because I need to know what this number is. It's a number. I just got to figure out what it is. So now what I'm going to do is I'm going to rewrite each number, 8 and 16, as a power of 2. So again, rewrite. Rewrite as a power of dos, okay, of 2. So here we go. So 8 is 2 cubed, raised to the Z power, and then 16 is 2 to the 4th. Okay, again, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. Just keep on multiplying by 2. And here we go again. If the bases are equal, the exponents are equal. All right. Now we know that when the power to power, you multiply. So I kind of skipped a step. So let me go back. So power to power, you multiply. So 2 to the third power raised to the Z power is 2 to the 3Z power, and that's equal to 2 to the 4th. And that means that 3Z is equal to 4, and that means Z is equal to 4/3. Which means this log base 8 of 16 is nothing more than 4/3. So I'm going to take this and bring it over here. Substitute it in, because now I know what it is. And now I've fulfilled my goal. I got h of x in terms of w, or I found my composition, which is what they want. All right, so w divided by 4/3. And as you guys know, that's the same thing as w times the reciprocal. So this is x is equal to 3/4 w. And there we go. Oh, yeah. And that's it. And there's your homework, my friends. All right. Now, if you can do all this, you know something. Okay. And so this Ainsworth is a video, so watch it again if you need to, and practice and mastery, and do your best. Give your heart and soul into this, and I'll see you in my next lesson. Bye bye.